I picked a couple of these up at an electronics flea market recently, and they've got some kind of neat properties, so I thought I'd do a short video on them. This is a dichroic mirror, also known as a dielectric mirror or Bragg mirror. And the way it works is it's essentially a notch filter for light that they're used in for lasers. So this one's meant for a neodymium doped YAG laser, and they use something called thin film interference to create that filter. And here's essentially how it works. You have three layers: the air on the outside, the thin film, which is usually a couple nanometers to a couple microns thick, and then the glass. So an incident light wave hits the surface of the filter, and you get a reflection and a transmission. And then that happens again at the next intersection of the film and the glass. You get another transmission and another reflection. So because the index of refraction of the air and the glass is less than that of the film, this reflection will be phase shifted, but this one will not. So what you end up with is these two reflections that one is phase shifted from the original light source, the other is not, and so they combine, and this interference creates a new color. So based on changing this angle, you can change what this phase is, and so you get a different color when these two combine. So if you look, see if I can get it to work here, you can see it sort of changing from red to orange to yellow a little bit. This same effect happens on some beetles on their carapace, and it also happens on the feathers of peacocks. And for a long time people thought that it was an actual color on the beetle or the peacock, but they later discovered that it was actually essentially the same mechanism happening at a very tiny scale. So anyway, that's a dichroic mirror. They're pretty cool.